right. So introduce yourselves now and tell us what grade you're in too.
I'm Tommy Cruz, and I'm in 11th grade.
I'm Daryl Underwood Jr., and I'm currently in 11th grade.
I'm Marley Underwood, and I'm in 11th grade.
I'm Cordell Hunter, and I'm in 12th grade.
And we've had a lot of Underwoods in our program, so you must be. So that's really cool. All right. So now you want me to share my screen? Hopefully, I know how to do that. Entire screen, share, and let's see. I'm so good at this. You guys all do better than me. Let's see. I want to go to, I have it on the down below here. Let me see if I minimize that. There it goes. Now do you see a PowerPoint?
Yes.
Yep.
Okay, now I have to put, do I put slide? Or
Slideshow.
Yes.
slideshow? Is that there?
To the
Yeah.
right.
Yep. You should look for.
That's just slide.
Actually, I usually go to,
View,
view's another one. There's a couple of ways to do it.
slideshow.
Yep.
There we go. I did it. Okay. So you just introduced yourself, so we'll move to the next slide.
Define the problem you are trying to solve. Design, build, and test a fully functional 2U Nanolab for a material testing system, where NASA researchers can explore the fluid physics of different potential growth media materials to improve upon the design of spacecraft production systems for space.
Awesome. And actually, Nancy, who's on this, is a microgravity fluid engineer. Is that right, Nancy?
Yeah. Fluid physicist. Yeah.
Yep. And this is, by the way, a physics class.
Great.
Okay, next.
Identifying criteria and specifically specify constraints. Design something that takes less space. Include the opinion and method to change the growth media materials. Have a method for moving fluid in and out of the growth media. Include any required sensors, electronics needed to study overall system to be self-contained, programmable circuit board, camera, lights, so camera can record, especially when Nanolab is sealed, sensors, system will have continuous power via A5V USB.
Yes, that's a perfect. Oops. Hold on. Uh-oh. Next slide.
Pool noodle experiment. The pool noodle is our second best experiment because the seeds germinated fast and the pool noodle held water. How we started is by adding water to the jar. We closed the lid and waited until we seen signs of growth. We also collected data from the movement we first planted the seeds in the first pool noodle to track their development over time. It only took a week and a half for the seeds to germinate and begin growing.
Wow, what seeds did you plant in there?
I was going to ask that too.
We planted radish seeds.
Radish seeds. Wow. And so were those, I have to ask this, did you use those pool noodles this summer or did you have to go buy some?
Oh, we had leftover pool noodles that we had left over in our lab. So,
Oh, okay.
yes.
That's
So
a crazy idea. Who would ever think that they could grow seeds? I have not heard of that. So that's really awesome.
I have a question.
Yep.
In microgravity, if you put water in the pool noodle, will it rise out or stay inside the pool noodle?
Well, the pool noodle is porous, so I think it'd probably, if you pour it on top, some of it will stay, some of it will go, because it's an interesting question. Yeah, I think part of it would go in there, the rest would just float away. Yeah.
Well, I was thinking surface tension. So the pool noodle would have a lot of little holes and a lot of surface tension, which would help keep the water in, because in microgravity, tell me if I'm wrong, Nancy, but in microgravity, surface tension becomes
more prevalent. Yep.
than in when we have gravity. So
Yep.
anything that is porous like that would be a good growth medium to hold the water.
Yep.
Did that answer your question?
Yeah.
Okay.
Sponge experiment. The sponge is our most successful experiment right now because there is signs of plant growth. We have been working on this experiment for about 2 months, and we only added water to the sponge about 2 times. In
Wow.
those 2 months, the sponge holds the moisture of the water pretty good.
So it wasn't a closed container, it looks like. You put a plastic wrap on that sponge.
Yep.
And you only had to water it twice. I have to show you my tomatoes on the sponge. This is about 3 months of growth. Once they start, but I'm actually using a nutrient in the water too. Did you use anything in the water that was a nutrient?
Not that I know of.
Yeah. Well, if you use the nutrient, this is what happens to it. That's pretty awesome. Okay. I'm going to go to the next one. Whoops, went wrong way. Oh, there it is.
During this project, we used 150 milliliters for each time we watered. We started the project on 10, 20, 25, and still going. We plan to test the pool noodle in similar ways as we explained in the slideshow below. We are trying to find a good system that will be easy for the astronauts to use without any hassle like water leaks. Yep.
Cool.
Yep. How to water the system. We are currently finding a way that works well to push water through these systems. We currently have some ideas sketched up. The top sketch is the sponge idea to grow plants. We could water by using the force of squeezing the water bag to push the water past one of the wave valves. The
I like
valve
that.
is meant to create a one-way path to the sponge and prevent water from coming back through. The bottle sketch is our idea of using a pool noodle to grow plants by planting the seed on the outside of it and feeding a hose that has small holes punctured through it and sealing the ends with silicone to give it a seal to hold the water. We plan on using a one-way valve to prevent water from coming back through the hose.
So in both of these, is the plan just to keep the water there? Is there a way to remove the water from the plants or the system?
You can gotta find a way to push the water through the pool noodle.
Oh,
So the excess water could go back to
so on the pool noodle, we'll have a valve to exclude the exceeding water from the pool noodle,
Okay.
Yeah, like the hose.
like a hose.
Yeah, because that's one of the concern with the plants is they'll plant or when they're feeding, when they're watering the plants or watering the vegetables, the water just stays there and then you get root rot. So you want to be able to remove that, the water
Right, you want the water to go in
Oh,
and
and to be
then
taken.
go out.
Yeah.
And so the pool noodle has that big empty circle in the middle
Mhm.
where you're going to put your hose kind of thing in there to water it, which is a unique idea. And
Yeah.
and I like also the idea of squeezing the bag. Never thought about that you could squeeze the bag. Most people are thinking of a syringe to push the water in, but yeah, you can squeeze the bag. You could squeeze the medium to get the water out of the sponge. You got a system for squeezing stuff. All right, I'm going to the next slide. Oops, wrong way, right? There we go.
Brainstorming, sponge. The materials we are going to be using is a sponge, some silicone, a one-way valve. Part of the hose will be inserted into the sponge. The hose will be inserted about halfway into the sponge and sealed off with silicone to prevent water from leaking. Our idea we currently have to water this system is using the water bags that they have on the International Space Station, and the use of the force of squeezing the water bag to push the water down the hose. We are trying to find a way the bag could connect the hose to the bag. Pool noodle. The materials that we are gonna be using is silicone, a plastic hose, and pool noodle. The way we are going to seal the ends of the pool noodle is by using silicone to hold the water in on the inside. The silicone would be applied around the hose and ends of the pool noodle. We plan on adding one-way valve to the hose so water can be pushed through and be prevented from coming back out.
Okay, so the bag, I have a bag here,
Oh, for my says.
right? Is this what you're talking about? That you're going to have some water in there?
Yeah.
Okay,
Yeah.
and you can get this exact material. They buy it from Capri Sun. Capri Sun actually supplies the material for
Oh.
this bag. And so just drink a few Capri Suns and then cut the bag and make it work the way you want it to. And you'd be using the same material as in here. So that's pretty cool. So I'm not quite sure how you were going to attach this, because these bags only have a small. Were you going to use these bags, or were you going to make your own type of bag?
We're going to make our own type of bag.
Okay, that makes sense. Okay, I'm going to go on to the next slide. Oh, look at that.
Plant growth of agar or auger. Plant this one failed, and we dropped this project after 3 weeks because we were seeing no plant growth or germination from the seeds. The agar was not suitable for the seeds from my analyzation. It looked to be too thick for the light to hit the seeds and seemed to lack the moisture of the seeds needed. I also think that agar lacked the nutrition the seeds needed to germinate.
Well, Well, that is really interesting because we did send a plant growth chamber.
Yeah.
Actually, it was with algae growing in the auger.
Mhm.
And the
Yeah, where was this? Yeah, where was the seeds? Was the seeds on the agar, or was it
It was inside the agar.
so you
inside?
punched a hole and put it in.
Yeah.
Did you
Okay.
get mold
No,
growing?
no, no.
Because
Yeah, I know that's
that
surprising.
would, yeah, that is surprising because mold likes to grow in that.
Yeah.
Did you
But
make
they said
it?
they put it inside, so maybe, yeah, like you said, maybe it was. He brings up a good point. It was too thick for the light to hit the seed. So if you have it inside, that may have been it. What would be a good test if you have time is put the seeds on the outside and see if it'll germinate or on top, not as far inside.
Yeah, that would be an interesting test. And you need to be able to show all these results too. So don't keep it in your your
Yes.
notebook there. They all
Yeah,
have notebooks.
and take pictures. If you're running this for 3 weeks, every day or every few days, you should take a picture, and you can include that in your presentation because from the picture you can talk about what you see, and you can say day 1, day 7, day 14. That also helps.
Yeah, because you've been doing that like for 3 weeks. That's
Yeah.
you've been working on this. So thank you. All right, next slide. Is that the last slide?
I believe so.
Yeah, it is.
Okay.
Yeah, that's the last slide. 9 slides.
So, do you guys have any of that stuff that you can show, like your the sponges or the pool noodle or anything?
Yeah.
Yeah.
Yeah, the auger experiment kind of blew my mind too, because a few years ago we did the nanorack experiment.
Mhm.
The girls programmed our pie, and they grew in auger inside that nanorack with lights and stuff, and they grew. I don't know why it didn't grow this year,
Yeah.
but it has before in
Yeah.
the past.
Yeah.
How many
it
seeds
could be
did
the
you use?
seeds or something else. Yeah.
And we use the same seeds and everything.
Okay.
I mean, radish seeds, but yeah, so I was surprised too, because it should have grown something based on our last nanorack experiment we did.
Yeah, I would try again.
All right. Do you guys have something to show there?
Yep, here they come.
Okay, so
Oh,
they're
cool.
all right. And you've got some seeds that are growing in it. Now, can you guys tell how well the roots are getting into the pool noodle?
Take one out.
Are you pulling one out? Hold it up a little bit so we can see. Oh, yeah. Interesting.
Okay.
Oh yeah.
So part of the reason why a pool noodle floats is because it doesn't suck up a lot of water. Each of the little air pockets in there is sealed so that it can't take on water.
Yeah.
And so I suspect that you're going to have the places where you're going to have seeds grow are the little nooks and crannies where the root is able to make some kind of penetration inside.
Yeah.
Now, the other sponge that you have looks like a natural sponge. Yeah. And it looks to me like those roots are able to kind of
Oh yeah.
go
You can see them.
sponge.
You can
That's
see
really
them.
so I kind of suspect that you're going to have that the natural sponge is going to be the more likely material to be able to allow that water to get in.
Yeah.
But I'm really curious. You know, I don't know everything about sponges and pool noodles, so keep working on this. I think it's really exciting what you guys are working on.
Okay.
Yeah, I didn't even know pool noodles why they floated. So that was interesting,
Yeah, that was
Glenn.
nice. Yeah.
Yeah.
Yeah. Okay.
So
Now I got to ask about your sweatshirt before I go further because I see that you're a cross country runner. Did you go to state this year?
Huh?
Did you go to state this year by any chance?
Yeah.
good.
Congratulations. Um,
That's
what
awesome.
what did you run?
Huh?
What did you run?
Like
What was
time?
your time?
It's a 1915.
That's pretty cool. That's awesome. How'd your team do? You guys do pretty
We
well?
got second.
You got second? Holy crap,
Nice.
good.
Good job.
Okay, I used to run cross country, so anytime I see somebody with a cross country shirts, I gotta ask. Okay, good job, sir. I'm very.
Wow.
All right, thank you.
Congratulations. So do you have any questions for us?
Uh,
You got the experts here.
see, come on,
No.
Um, there's a lot of water system. Yeah, that's the next. Yeah, that's
All right, does our system look good?
For the water.
Like for like the water system and all that? Overall?
It looks good. The thing is, remember for the Nanolab, it's a small container. So
Mhm.
you're gonna have to manage how much water. And like I said, is one of the key things is to move the water back, in and out. I like the fact that you guys are doing research to determine what the materials, how well it grows. So all that initial research will be helpful. I would just say watch how much the container you have is very big. I can tell you won't need that much water, but but your testing is helping you determine what, and I'm calling it the substrate you're going to use. It's helping you determine what seeds you're going to use, and it's showing it can grow. So yeah, I would say yes, you're on the right track now that you got that. So tell me, what's your next steps once you finalize these two? What are you guys going to do next?
We're gonna continue.
Are you gonna retry the auger?
What was that?
Retry the auger with
Okay.
see if it could grow some stuff in it.
Yeah. Well, I would say my suggestion is do the auger is good, but look at between the sponge and the noodle what it does, but start working on the Nanolab container too. There's
Okay.
several of you, so I would recommend splitting the job. Go ahead and look, see what's happening with the auger, but also start looking at the Nanolab. Where would you put it in? We also need sensors. Yeah, Glenn has a picture of what the Nanolab box should look like. So notice how that is compared to your container. Your container was almost as big as that. So you just want it in a small compartment, and then you have the electronics and everything else. So yeah, since I'm glad you guys have a pretty good sized team, split up the work.
Yeah. So, and for your first prototype, you don't need to make it out of aluminum or anything, but you need to start figuring out what your dimensions are so that you can figure out how you're going to fit those things in. Does that make sense?
Yeah.
Yeah.
Okay. Um, let's see. I think you guys are on a good path. You've got some good ideas. So for example, I've seen some of the other ones, and they take like two flat panes of like clear plastic, and they put their substrate material in between. And I think that's where you would be, slicing up a piece of sponge material and noodle material and seeing putting them between these panes and then seeing how the water will percolate through there or how it will be absorbed and see how visible it is. One team was talking about using colored water to help with that visibility. And I thought that was a really smart idea as well. Okay.
Yeah.
Good job,
Awesome.
team. I like
Yep.
where you're going with this. Keep this up.
Yeah. And ask me questions. I really appreciate you doing this, and you can send me questions anytime. You should copy your teacher, but I kind of know who you are. So that would be awesome. All right. So you have a wonderful afternoon there, and you have another team.
Oh, is that
presenting
right? We got another
yeah,
team?
they have one more and they're doing the lunar sample box container. Is that right?
Yeah.
Yeah.
Okay, so enjoy your afternoon.
All right.
Thank you so
Awesome.
much for your
Thank you.
presentation, and your research is awesome.
Thank you. It was nice to meet you guys.
Yeah. Thank
All
you.
right, bye.
Thank you guys for your time. Thank you.
Thank you.
Yeah, I don't think I've seen any of those yet. So cool.
I like that they're twisting the bag.
Yeah.
They could twist the sponge and get the water out, and then add more water. Well, hello. How are you?
Good. How are you?
Good. So, did you hear our two reviewers introduce themselves earlier? Do you know who we got? Or were
I
you?
didn't catch
All
it.
right.
Okay.
Okay. So, Nancy, will you introduce yourself and then
Sure.
Glenn?
Yeah. So my name's Nancy Hall. I work at the NASA Glenn Research Center in Cleveland, Ohio, and I'm the HUNCH regional mentor. And I mentor students in my region, which includes Michigan, Minnesota, Wisconsin, Missouri, and parts of New York. And I also help Flo out with her teams. So looking forward to hearing what you guys are presenting. And Glenn?
Us.
Well, ladies, I'm Glenn Johnson. I'm at Johnson Space Center in Houston, and I work with engineers and the mentors and the astronauts to help come up with these projects. And so like you guys are working on the lunar sample box. I've been working with some of the different engineers to learn more about what kind of lunar sample boxes we need. And so I'm excited to see what you have to say.
All right, ladies, introduce yourselves.
My name is Joy Bogan. Oh, and I'm in 12th grade. Hello, my name is Jayla Norris. I'm a senior at Bumpkin High School. Hi, I'm Tayavi Dixie, and I'm in 12th grade. Hi, I'm Fury Trumbull, and I'm in 11th grade.
Awesome.
You're gonna have to speak a little louder. I could hear you, but you guys were real soft. So I need you to, when you go ahead and give your presentation, Flo, do you have theirs or they're gonna share it?
No, I have those too. Hold on. Let me go to share, entire screen, share. I think, do you see it?
Okay. Yes.
Let me do the slideshow view. There you go.
Alrighty. So, we're working on the Artemis lunar sample box and prototype projects. So the problem was when Apollo astronauts landed on the moon, they had brought back rock samples, right? They were stored in specially made aluminum boxes intended to keep air and water out of the box. But unfortunately, the boxes leaked onto the samples. To solve this problem, we would need to create a box that is extremely light, but big enough to fit 2 baseball-sized rocks. So we need, so our criteria and concentrates, we need something that's lightweight, can endure lunar environment, big enough for 2 big baseball-sized rocks, air and water tight, and very sturdy.
Awesome. Oops.
Flo, you went forward 2 slides, I think.
Oh no, hold on.
Oh, okay.
For my research, aluminum would be an efficient material to work with just because 1 is considered to be very lightweight and 2 is the material is also sturdy. A gadget we also would like to include is a vacuum seal to avoid samples from being contaminated. Some ideas from our group had come up with are to include sturdy handles for easy handling,
vacuum sealed lids to prevent contamination and to resemble the shape of a tube or a bucket.
All right, developing proposing ideas along with alternate solutions. We had looked at the Stanley water bottle and wanted to resemble the shape of it and include a pretty hefty handle. We considered the fact that astronauts will be wearing big hockey-like gloves. A small handle would not be so beneficial. Therefore, we agreed to create a big enough handle for easy handling. Another idea that we had was to create a lightweight bucket, small but big enough to hold 2 baseball-sized rocks. We want these samples to be extremely lightweight simply because 1 pound can cost millions of dollars. The bucket would also include a handle and a vacuum-sealed lid. Mentioning a vacuum seal, this would prevent samples from being contaminated by air and water, which was the problem there before. And then these are some of our ideas that we drew up.
With the water bottle, instead of it like coming in, we would like make it like pretty consistent, like just like a tube, like I guess.
Mm-hmm.
Yeah, see,
Now,
Same with
do
the
you guys
bucket.
have one of the Stanley cups that you're talking about?
Yeah.
Let me see.
She'll be right back.
Okay, go ahead and talk some more here. You're doing just fine.
Yeah, and also with the bucket, instead of it coming like inwards, like how we drew it at the bottom, I think it should also just be like consistent shape. You know what I mean?
So it's just a
be
straight down,
Yeah,
straight, yeah.
so they're not stackable,
Oh, I
right?
see. Okay,
Yeah.
nice.
And so here, tell me about the lid that's on that one.
The lid, it's just a rotating one.
Uh-huh.
And then on the top, there's this.
Uh-huh. Now
And
where
you look. Okay.
Because if anything,
Oh,
we can close it.
I see.
And then let me take the straw out. Sorry.
Yes.
But like we can seal it. And then with how it is, there's a circle with this. We can air seal it here and then we can
Uh-huh.
pop it back on.
Oh, nice.
Now, when you take that lid off, are there any little rubber seals or gaskets inside, either on the lid or on the cup?
Yeah. Yeah.
Okay, so that's what you're
Hold that
looking
up to the
at. All right.
camera. Let me see what you got there.
It's
So
the
there's like a little
Yeah.
like rubber
Oh, it's
ring,
a
so it like prevents it to like leak.
is that like so it's a rubbery material right there?
Yeah.
Yeah, okay. And I can't see
Okay, I
it.
see.
Yeah. No,
I
that's
guess,
really
you want me to stop sharing?
yeah, let's stop sharing
Yeah,
for a
stop sharing for a little bit. Yeah.
there it
Oh,
is.
there
Oh,
it
yeah.
is.
Yeah.
It's clear.
Okay.
That's
All right.
nice. Yeah.
Ladies, I think you're really smart for looking at some of these different things because that's a very simple holder that we, even though it's not the right size for a couple of baseballs, it's the right idea. And I
Yeah.
think that's really smart. Now, here on this mug, you've got there's a handle on the side. Is there a reason why we want to have a handle on the top?
We're thinking it'd be easier for the astronauts to carry because you could do this or you can just hold your hand up simply. This is
I'm
all.
Now,
okay with
are you looking at both having on the side and the top, or just one on the top?
That's something we're thinking about right now, which is one our ideas, which one's gonna be easier.
Okay.
We're looking at getting
Yeah,
some.
one way you can test that is because you mentioned the astronaut's glove is if you have welder's glove or a mitten, you try using that and see which way is easier to hand,
Yeah, we
to
have
handle.
like pretty big hockey gloves to like
Yeah.
test it.
Hockey gloves is perfect. Yes.
that's really smart.
Yes, that's
Okay.
good. Use that in your testing and see which one is it easier to use.
Well, and one of the things I liked about your idea is also, if you have the handle on top instead of the side, when the astronaut takes it into the lunar lander
You
and
just
they
put
start putting all of these samples in, the side handle would be in the way. but the top handle would be something where I could put it into like a milk, like the cartons that hold the like
Yeah.
Like
several jugs
eggs
of
and
milk or
milks,
something like
yeah.
that.
Yeah.
So I think you guys are on a really smart idea there. Um, and so now they don't make those big enough for baseballs. Do you have an idea of what you want to use as your next prototype?
Mm, Um, we're still kind of like
We're thinking,
brainstorming.
yeah, we're thinking of using our 3D printing and
Yeah,
seeing how big we can 3D print one of these.
I think that's a
Okay.
great idea. And it probably doesn't have to be as tall,
Yeah.
right? So it might be a little bit shorter. Okay. Um, now, okay, so 3D printing one, it makes good sense. And I think you guys were talking about, the one that we send to the moon would be made out of aluminum, right?
Yeah.
Okay. And I think that's also really smart. Um, the So, it might be that lid, the handle for the lid, that will determine the size. Does that make sense? As
Yeah.
opposed to the baseballs themselves. Um, Now here's another thought. I put one in, and then I'm going to put in another rock on top of it. What keeps them from bouncing into each other and breaking apart or anything?
So we haven't considered that, but we will like think about it.
Okay, I think that's a terrific answer. Just put some ideas in your head. Now, one of the difficulties that NASA is looking at also is that they want to make sure that whatever materials they use, they're not going to contaminate it. Okay. So, for example, we're talking about a specific type of stainless steel, and I don't remember which one. Uh, Aluminum, and it's probably a 6061. It's a specific aluminum. Don't worry about that yet. But then they're okay with Teflon, but they don't want to use other plastics. So just be aware of that. I don't expect you to have to use the exact materials, but keep it in mind that they are wanting to use very specific materials so that they don't contaminate their rocks. Does that make sense?
Mhm.
So
All right.
what materials would contaminate the rocks?
Well, okay, so imagine I use
Plastics, yeah.
Yeah, if I use different plastics, if I have different types of stainless steel, then I start, um,
Yeah,
it just makes it more difficult for me to isolate which one
yeah.
did I send and which one am I picking up on the rock. Does
Yeah,
that make sense?
depending on the materials, because you're gonna have the container, it's gonna move, and depending on the materials inside the rocks, can brush against it, or can pieces of it can fall off, get embedded. Then you're like, okay, is this the rock or is this the material you brought it in? That's why when we send things to Mars, we sanitize it, especially when we're looking for life, to make sure it doesn't pick up stuff we brought with the vehicle there.
Yeah. So they're very particular. You
Yes.
guys don't have to be as particular at all, but be aware that those are some of the questions you might get asked. Okay? Team, I like what you're doing. I like your ideas. Now, you guys were showing a couple of pictures there. Did you go beyond that?
Oh, let's see. I'll share again. Hold on.
Yep, you guys had three different buckets or three different containers there.
Yeah. Let's see. Yep. Oh, here are their questions next.
Okay.
The first question is, are there going to be two separate containers? Meaning that is there going to be one container going up like to the moon, and is there going to be another container, like a different one, coming back down?
Oh, no, it'll be one container that goes there and one container that comes back. Now,
Yeah.
you can
The
imagine
same one.
lots of
Mhm.
containers. But yeah, the same container that goes up is the same container we want to come back.
Mhm.
I like that. I like question number 2. Is there a need for different compartments in the sample container? Um, yeah, I would
And
think
go
depending
ahead.
on where it would be nice to have it because depending on where they go, if they go one area versus another, they can identify which rocks they got. Yeah.
Well, I imagine that they might, the astronauts might be on the moon and they would say, hi, this is the rock that I think we want to bring back. I've got a plastic, what do you call it? I've got a Teflon bag here. It's numbered 1250. I'm putting this rock in here. I'm closing it. And now I'm putting it into container 2231, right? And then they go over and they say, "Oh, and you guys said you wanted a baggie of dirt from this area. So here's a couple of scoops. I'm putting into another baggie, and I'm closing it, and I'm putting it into that same container. I'm closing it up, and this is what I'm going to bring inside." Does that make sense?
Yeah.
So they're going to be trying to identify anything that they're going to put into that container, and they'll be calling it as they walk around. Okay.
So we don't want one rock to contaminate another rock that's in there. So it
I
makes
think I'm expecting that they're going to be putting them into bags, and it just helps them identify specifically where they got that from.
right. And it won't contaminate them that way.
That's right.
All right, third question.
Oh,
How is the sample container going to be stored during launch? Is it going to be held or tied down?
okay. You're asking exactly the right question, and I'm going to let you guys decide that. Okay. And what I mean is, so whatever your container is, however you decide it to be shaped, I want you to be able to tell us when they walk back in, how do you think that they should store it on the spacecraft before launch? Are they going to have like a crate and they stick each one of them into there? Are they going to have some kind of like a shelf and they slide it into place and then they have a door that closes it and keeps it in place? You guys can decide that. Is that okay?
Um, Another idea I just like now came up with is like insulation for the sample container. And like I was just wondering how we would make that happen and like what kind of materials like we could use that wouldn't contaminate.
You are asking a really smart question. Okay. So potentially they might walk into one of these craters where it's negative 400 degrees. Okay. They're going to grab a rock and then they're going to put it into this container. And now, as soon as they take it into the spacecraft, they're going to warm it up to 71 degrees Fahrenheit. Right. And so, what kind of, so that Stanley cup that you've got, what's the insulation in that Stanley cup?
I think it's just stainless steel. There's
Right. Now, put your fingers in there. Is it really thick, or do you think it's hollow inside?
thick.
Is it thick?
Yeah, it's
But
thick.
but is it heavy or is it lightweight?
Lightweight.
It's pretty lightweight. So there's probably an empty space in between there. Does that make sense?
Yeah.
And so the air pocket from the inside to the outside is how they've got some insulation. How about yours, Nancy? I see you're grabbing one.
Yeah, that's what I was doing it to look. So I know there's insulation. Yeah, this is what mine looked like. I know there's insulation because I could put cold water in here and it'll stay cold. And the way I can tell is just by looking at, the distance between the lip and over here. So I know
Right.
there's insulation. But yeah, it is very thin.
Yeah, I suspect that either they have a layer of air in there,
Mhm.
or they might have like some foam material that they've installed, and then they put the second piece, the
Yeah.
second metal piece on the
Yeah,
inside.
and mine has a handle on top, and I like the handle because it's easier just to carry that way.
See, and so I think they're on a really good path.
Mhm.
Um, so how do you want to do your insulation? Look at some of those other mugs and see if they have other ideas for you, because I think you're looking at the right kind of technology. Okay?
Uh-huh.
Good job, team. Very good questions.
Thank you for your time.
You
Well,
bet.
thank you for working on this project. Thank you. All right, ladies, have a great afternoon there.
You too.
We appreciate your work.
Yeah,
We'll see
Flo,
you
is there one more team? Or is
No,
that
the jumping robot team isn't in class today, I heard.
Okay.
Okay.
Yeah.
So that's the last team as
Okay.
far as I
Hey,
know.
Next.
Flo, if there's a time when you're, I'd like to go out and see this school sometime. So if there's another time when you're planning to go down there, give me a heads up, okay?
Oh, awesome. Yeah.
I'd love to see Scott's class. I think this is great.
You should see his sewing room.
You bet I'd like to see that.
Do any of you ladies do some sewing in there? Yes,
Oh, that
I
is
thought so.
All right.
That's
All
really
right. Thanks a
cool.
lot, teams. I really appreciate it.
Okay, thank you. Thank
All
you.
right, thanks, Flo.
Nancy, I actually want to talk to you a
Okay,
minute.
I'll hang
Ben,
out a
you
little
can
bit.
stay. Yeah, you can stay too. Scott, did you?